Awesome, we have slides. All right. So, we've heard a lot about exciting technologies like Bluetooth, cellular for connectivity. Let's talk about the technologies that kind of fill that out so we can build an Internet of Things. And the Internet's all about connecting lots of heterogeneous networks together into one big network. That's what we did with the early days of the Internet. We're seeing the same thing happen with IoT technology for devices. Lots of heterogeneous technologies, let's bring them together into one network. But if people remember the early days of the Internet, it wasn't about the web and all these things yet. At first, it was just about telnetting into your professor's website where they had the syllabus for the course. I don't know if anybody remembers those days, I do. Or there was like Gopher, that's how you got the professor's homework for that week. That was the Internet in the early days. But then we got the web. And I'm going to talk about why the web's exciting for all these IoT networks, because it's the web, the technology, security that really ties everything we do together. So we're all building a big network, IoT, with web. It's the theory of today's talk. So what is IoT really about? People think it's about developing devices. Well, yeah, we like to develop devices, but that's just one piece. Is it about developing cool services? Well, yeah, that's the other piece. But I think it's really about connecting devices and services together. And the common factor we have for doing that, it's not just the Internet protocol. That's great. I can ping. Ping is fun. I like ping. I can do traceroute. But with web technologies, we actually connect those two things and make them talk a common language. So I really see the common narrow waist of a lot of the technology in communications. Forget about programming languages, communications. It's REST, it's the web. A set of web technologies we use to build things. And so IoT is really about connecting things to services using web technologies. Talk about some of those, what we're doing now in mbed, exciting stuff. It's also about the little data connecting into the big data. This is a big theme for us at ARM because people talk a lot about big data, we do these cool things with applications, but if you don't have these little streams of information that aren't reusable, you'll never have big data in the first place. So you need the little data first, and that's what we do. And to make that all happen, make it all part of the Internet and part of the web, we've done a lot of work over the last 7 years. So I was the co-founder of a company called SensiNode, did a lot of work on standardizing technologies for IoT and the web. Now as ARM, we're really looking to make this something that the whole industry can use. So we want to make this interoperable ecosystem, something that ARM does really well. And what we've done is we've brought technologies together that let us do things like you'd normally do in a web stack, thousands of bytes. We can now do that in hundreds of bytes over cellular. We have traditional IP, but we can do full PK-based, TLS-based security. We can do web in a new protocol called CoAP. I'll explain what that is. And we have standards now for the actual data formats, not just the web communications, but small data formats that people can reuse in applications called binary web objects. Put these together, we're down to hundreds of bytes. We can go even further than that if we actually go into a low-power network, something like Bluetooth Smart, 802.15.4, satellite or long-range telemetry radios. We can use a technology called 6LoWPAN, which lets us do IPv6 in just a few bytes. So we can actually do useful web transactions, completely secure, in tens of bytes. That's technology. Then we have a really interesting set of standards for communications that we can go build this stuff. And these exist. These are all standards that we've done at the IETF that allow us to build IoT and web-based systems. So now we have to go out and build. How do we do that? And that's what mbed's about. That's what ARM SensiNode's about. Now, why are we talking about technologies like 15.4 or BT Smart in addition to cellular? Why don't we just put cellular everywhere? And something we realized a long time ago is that actually cellular as a market, although it's already fairly well established, yes, it has growth, the growth's linear. It's a pretty mature market, so we're not seeing the huge growth ramp anymore in cellular. Very important part of our deployments, but actually the big growth we see is in local wireless. And one example is street lighting. The street lighting systems that we provide, we're providing most of the software for some major global players in street lighting, the ratios that these guys are aiming at, it's 500 to 1. 500 802.15.4G 6-LoWPAN lights behind a single cellular router. That tells us that we need to get in the business of IoT, not just M2M. So we need to provide services all the way down to those cellular plus sensor network devices. We need to manage them, do security, provide services, because that's where the big growth and potential revenue is. It's in local wireless. So let's make services, solutions, software, protocols that work over all of these technologies. Let's not just think cellular or just think sensor. Let's just think IoT as a whole. Now, what's 15.4? People talk a lot about it. People confuse it with Zigbee, which is a proprietary way of building networks in the old days. But 15.4 is really just an open MAC plus PHY solution, like 802.11 is for Wi-Fi. 15.4 is the exact same thing for sensor networks. So it simply defines the few different modes of MACs, a couple different modes of PHYs that you can use to build networks. And the great thing about recent technologies in 6-LoWPAN is that we can use those now to build IP-based networks, just like you could with Zigbee for local Zigbee networks. Some of the interesting trends here are things like 802.15.4G. This includes a lot of improvements for sub-gigahertz. This is what has recently really opened up the 15.4 6-LoWPAN market for sub-gigahertz long-range applications. So this is what we use in street lighting, AMI, metering networks, and things like that. And that kind of complements the existing 2.4 gigahertz support. And there's kind of advanced MAC technologies that come under 15.4E. So very well established technology. We think with the advent of 6-LoWPAN technologies, new standards, that this will start to take off, not only in smart energy 2, but in other areas. So we'll see growth in this space. Now 6-LoWPAN is a technology that is simply, and it's really a simple technology, it just finds a smart way to compress IPv6 for these types of networks. It just takes all the useful stuff out of IPv6, compresses it down into 3 bytes, gets rid of the useless stuff you don't need on that sensor network, and then compresses UDP. So in about 7 bytes, you can get IPv6 and UDP. It's a very simple technology. We've also optimized some of the complementary things in the IETF, like neighbor discovery. You need to build up your local network, or routing. So these are all RFC standards at the IETF. 6-LoWPAN's about 6-7 years old as a standard. So it starts to be a pretty well-established set of technologies. Now, the other thing to remember about 6-LoWPAN is it's not just about 15.4. So I'm also excited about BT Smart, but for a different reason. We actually have developed a standard for running 6-LoWPAN over BT Smart. That means in addition to the attribute protocol that was presented earlier, we can also run 6-LoWPAN web requests directly over BT Smart in parallel. So if you don't want your sensor to just talk to your phone, if you want your sensor to talk directly to the cloud, or if you want to use BT Smart in things like home automation or building automation where you don't have a phone, really exciting technology. So that's something that I hope at mbed and with our technology will be enabling that in the future. But it's other things too. We actually have a standard for 6-LoWPAN over DECT ultra-low power, 6-LoWPAN over power line communications like G3 PLC, and even 6-LoWPAN over Z-Wave. So Z-Wave is actually upgrading to IP-based technology at this moment. So we kind of have a 6-LoWPAN revolution that we see coming through the industry. And the architecture here is also very simple. So this is about connecting the last hop of the internet. This is not about making complicated routing scenarios where you're routing through a 6-LoWPAN network. None of that. We say that no, we're solving this is the last hop to the internet. It's the simple hop. You can build nice mesh networks there and things, but you're not going to use it as a transit network. And that allows us to keep this very simple. Now, in addition to 6-LoWPAN, you need a little bit more. You need something we call a profile, because if you know how IP networks are normally built, IPv4, IPv6, IP alone doesn't actually give you interoperability in your network. You have a system admin who configures how your IP network is set up, what the prefixes are. It actually takes some work to get an IP network up and administered. It's no different in the 6-LoWPAN world. The problem here, though, is we're not dealing with administered PCs, we're dealing with things, right? Street light, you don't want to have to go out and configure. So the way we handle that is through profiles. And surprisingly enough, the association that's got involved with profiles in 6LoWPAN is ZigBee. So in recent years, ZigBee's moved out of just proprietary networks into standard IP 6LoWPAN based networks. So the big standards in this space are things like ZigBee IP. This is the current standard for home automation using 6LoWPAN. We're currently working on extending that to cover a broader range of home applications. Right now it's quite Smart Energy 2 focused. There's BT Smart IP, which is a standard from the IETF, also supported by the Bluetooth SIG. We think that'll cover a good range of home and building applications. Pretty interesting. It's not going to take over the phone space, it'll take over other things. There's a new standard coming out of ZigBee called ZigBee IP NAN, Neighborhood Area Network. That's what we use for outdoor applications. We find that there's some stuff that's done in industrial that's kind of weird, real-time industrial things that we don't usually get involved in. So if you look at the compass, we're kind of covering this range of different applications that you could possibly do with sensor networks. Now we cover it with 6LoWPAN technologies. So it's a really interesting space to be involved with. Summary, well, I think we have a lot of opportunity here in the space of enabling internet. Now we're talking about IoT. That really does mean building internet networks. Enabling internet over lots of different heterogeneous networks. There's also a lot of barriers we want to overcome to make that even faster. Those barriers include, how do we get more gateways and router platforms available, both as platforms from different chip vendors and as ready gateway router products? How do we make development easier, get certifiable stacks and software technology into people's hands? And finally, how do we integrate this with the actual application protocols to build end-to-end applications? Those are all things that we have to do really well to make 6LoWPAN a big thing. And I'm confident that mbed's a great place to do that. That's why ARM Sensing Nodes, ARM mbed make a lot of sense together. Now, one of the things that we're looking for partners in mbed for is to make this a reality. We need to have more 802.15.4 based hardware platforms. We're very actively looking for partners in this space. We have the software technology. At SensiNode, we have a great range of stacks that we can provide to enable these things. We've got to get the right mix of hardware and software together to get that in developers' hands. And that's what we're really all about. How do we enable developers to go and deploy systems? Now, as I mentioned before, it's not just about the IP network, it's about the web. And this is actually the thing that excites me more than just IP. I've been doing IP for 15 years already, hooking these things together. We're done. You can go build IP networks. Let's not spend too much energy on that. We just got to make it happen. The cool stuff is with the web and what we can do in building secure applications that end-to-end work from device to services. And one key component is a new protocol that we finished standardizing at the IETF called the Constrained Application Protocol. And this protocol really does for IoT what HTTP did for the web, for browsers and humans. It gives you the ability to use all the web architecture, all the paradigms that we know as web developers for very small devices. And we managed to do this in a way that's really unique for a constrained device because it's done with a very compact header, 4 bytes, binary, easy to parse. We use UDP, very, very applicable to the asynchronous transactions that we have, discovery, multicast. We can use TCP. We actually have production customers up and using co-op over TCP if you have firewalls to deal with. And we have really cool things built in, like interoperable security with DTLS, strong security with DTLS, subscription built into the protocol, and discovery built into the protocol. So we've done some of the things that HTTP kind of missed the boat on because those were never requirements for web pages. They are requirements for constrained devices. Now, some of you might be asking, well, what does this have to do with the SensiNode acquisition? Why are you guys talking about all this? Well, it's because we have software products in this space. We are a software provider of technology for IoT and web. So some of the technology you have is in protocol stacks. We have a protocol stack called NanoMesh. We work very widely in the industry in making sure stacks are available to developers. So this is really an enabler for us. This isn't the end goal. This is the means to the end. And the end for us is enabling these whole applications. These stacks are to make sure that we have IP in the first place. So you'll see us do more and more about this in mbed. But more importantly, we're providing the technologies that give us the end-to-end security and application layer technology to hook things up from devices. We have something called a nanoservice client, show an example in a moment, to back-end cloud systems. And we actually provide the cloud connectors, something we call nanoservice platform. So from devices, clients, to the edge of the cloud, we're providing technologies. And we do that for a whole ecosystem of partners. We're really bringing the whole partner ecosystem at ARM together. That includes service providers, big data providers, and application examples that we provide. One important thing there is it's more than just a simple web protocol. You actually have to provide a whole interoperable system. And we've gone through the whole process of doing standardization around this interoperable device to service interface. So not just the protocol, but the whole security bootstrapping, security provisioning setup. We have developed an entire system around that, about the registration of devices, discovery, so how a device works with a service through its whole life cycle, more than just protocol, the system. And this is standardized through a standard called OMA Lightweight M2M, and that includes a data model that everybody can use. So there's work going on in the IPSO Alliance and in different vendors to create all the data model objects that you can use with this system. So think of it like Zigbee clusters, but for the web. You can actually use this in any web system. So really interesting stuff, and this is a standard we support in our software as well. So when you hear about the nanoservice support we're doing for mbed, you actually get access to this technology. We support this standard as part of what we do. And finally, the cool stuff, the demo. So one of the first things we did when we joined ARM, we're like, whoa, ARM, great, very cool. Oh, mbed, ooh, that's really nice. And the mbed guys go, ooh, these guys have all this application layer stuff. So we said, well, let's connect them together, right? So we're excited engineers. So first thing we wanted to do is get nanoservice support for mbed. And we have that. We've announced that today, that that's now available. I've been tweeting this morning that, go download this and start playing with it. And I actually set up a demo this morning during the lectures, or during the workshop. I wanted to show how easy this was, so I forgot Dan here had a demo ready. I said, no, let's not use that. I'll just try to make it work myself. So I just went and took the mbed project off of mbed.org, and let's go look at that. So we actually have an mbed nanoservice project now. This is at mbed.org components nanoservice. You see this in the news. It'll be easy to find. Just search for nanoservices. And this includes a C library. This is our free developer version of the nanoservice client. That's just something that automatically gets imported. And it's got a Hello World project. This shows you how to make a web-based mbed thing that talks to these services. And so you can actually just import this project into your compiler, your online mbed compiler. And I did that. I went and inserted the project. It looks like this. NSDL Hello World. And it's got a really simple main project that just configures where the service is, what kind of resources you have, what your device is called. And the cool thing is that we're also hosting a version of this backend cloud service on mbed.org. So we've gone and integrated our cloud technology, this very simple example application. We're ARM, we're not a service provider, we're not a cloud provider, but we wanted to show you how easy it is for an mbed developer to go and get data somewhere. After that, we hope that our partners like Telenor, like Xively, all the other cloud providers out there will go and take this data coming from users and help them create services. So I went and tried this, and what happens is you go to this website. There's a link to it on the page, nanoservicedemo.mbed.org, and you'll see all the different mbed devices in the world that are going and running this project. So this isn't just about you, it's about everybody in the mbed community going and posting their information on the web. And this particular project here is, this device that I have is called mbed Shelby 1A723. 1A723 comes from the ID, the unique ID on the mbed. And this has GPS location as a resource, so I can go and show this on the map. And I, of course, hard-coded our GPS location of this building. And so we have map support built into this. And somebody earlier was talking about, oh, we have GPS built into our board. I thought that's really cool because we can hook it up here. So when we have these U-Blocks versions of these devices, you'll be able to actually get the GPS data and see it on the map automatically. So make sure to come to the Thursday workshop. We're going to be doing a little bit around that. And this is more than just a WebSocket feed where you can do stuff. This is an entire framework for information, data, controlling devices. So I can get a little bit of information about the device, some quick information. And I can also get very detailed information, like the device model. I can get what the device model and maker is, the GPS location, things like temperature. There's an actual temperature sensor on there. And this little button here indicates that this is being observed. That means it's a real data feed that's automatically coming to the device. I can do things like LED control, so this works. Demo effect, I should be able to turn on the lights. Turn on the lights, yes. Lights turn on, and brighter, and lights turn off. And I should be able to use the magic buzzer that I've never tried before because it's probably horrible. Oh, it's not loud. I have a magic buzzer. And off. And the cool thing about this, we can do that, we can hard code that in any application. The cool thing about this is this whole application is built on standard data objects. We didn't code any of that. We didn't code the LED control, the buzzers, none of that. Those are standard objects that were predefined by these open standards. And the web developer, the guy that wrote that application, is a different one than the one that configured the application. And because we defined ahead of time what these things are, it's easy to go and actually build interoperable web applications with devices. And this just shows how easy that is. Now, the cool thing is, we can go in and play with other people's devices. It's the beauty of mbed, the mbed developer community. So I have another one here. I don't know whose this is. I think this is Dan's. I can go and turn on his buzzer. Somewhere over there. This is how you know your fellow mbed developers. So this is going to be the secret feature that nobody knows of.
So much security.
Oh yes, we will do security. Don't worry, but this is funner. And then this is the mystery device. This is somebody's device. I just don't know where this is in the world, but I think they're going to find out that we're doing this and that.
You're going to rip the battery out.
Oh, they're not in this room. Okay, it's probably some poor guy in Cambridge. I hope this is on one of your desks there, and somebody in Cambridge is going, "Shut that thing up." We'll turn that off. And this is now available to everybody. This isn't a special demo just for us ARM guys. This is now a public project, public website. Go and play with it, and it works on any Cortex M3 board with the app board. That's the current example project. We'll be doing it across all the mbed ports as time goes on. Back to the presentation. So simply what I demonstrated there was hosted simple platform, simple nanoservice client library on mbed. You can use that on any kind of device, cellular or a sensor network device, it doesn't matter. And the cool thing about this and what we do with technology, it's all software. So it's not just a hosted platform you can get, but you can get all the software yourself. So something we're announcing this week at TechCon, around Wednesday we'll be making the software available at arm.com under Silver. We'll actually be releasing this whole software package, a free developer version, including the cloud. So you can go and deploy that piece of software you saw on mbed.org on your own Linux machine, your own cloud server. Somebody mentioned Rackspace. You can go just install this on Rackspace if you wanted to. And then you just repoint your mbed project at that IP address. Simple as that. And there you go. You've got your own private cloud infrastructure for IoT. So really exciting stuff. So just as a quick summary, we really see a whole revolution happening in IoT right now. It's gone past just IP, we're into the web, and we're doing things the right way with web security, web protocols that are IETF standard. We're not talking about this company's or this company's thing, we're talking about the whole industry. We're enabling REST in standardized objects on REST to devices, so it's something that every web developer in the world knows about. So you don't have to learn new technology. You don't have to reinvent how people make web applications. You build them like we build web things today. So we have a huge developer community we can tap. If we do a good job at our APIs, the way we make development for this, we've really cracked it open for IoT. And finally, make sure to come check this out at the ARM booth, the Freescale booth this week. At TechCon, we've got demos, live demos going on. And Karthik already mentioned the hands-on workshop Thursday afternoon. We'll also have a session on using this nanoservice client on the uBlocks mbed board. So we're going to be teaching how to do that, how you can use cellular as a backhaul. This was the Ethernet version. That's it. I can take a few questions, and otherwise you can find me all week at TechCon, so just go grab me if you have something to talk about.
A question on the
Please speak.
is 6-mode plan going to be included in the plan software?
Absolutely, as soon as we have hardware. You always need hardware for doing something. So this is one of the things that we really are interested in enabling in the mbed ecosystem. We already release our stacks on lots of chip vendor platforms. So we've partnered with a large number of chip vendors. For example, the Atno Gallery. Recently we released a whole bunch of really interesting software packages where you can go and get this nanomesh technology, all the libraries, nanoservices as well, and develop. But we're looking to do that as an mbed ecosystem as well. We want it to be really easy with the online compilers and everything. So as soon as we have some great hardware platforms, we'll be doing 6LoWPAN on mbed as well. Absolutely. Another question?
Is this co-op being used by any of the smartphones that may be gathering sensor data?
So the problem with smartphones, okay, there's a couple problems with smartphones. First problem with smartphones is that most of these gather sensor data one hop away. You don't really need it, right? It's like BT Smart with the built-in attribute protocol. It's really all you need. So traditionally, you don't actually have to have it. So not a lot. We do see some of it, but it's kind of like people doing their own thing. So these protocols are very easy to include in a smartphone project. Like I can go and include our C library in an iOS project. No problem. You can bind to a C library in iOS. Our Java library that we give by default, it works in Android. Our guys in the office are like, oh, I want to monitor my GPS location on my Android phone. They go and use our Java library in Android and it works. I think it's just more a problem of the kind of radios that are included in phones, but you'll see more of it. I don't think it's just the main application. However, I do see in the future we're going to be seeing phones as routers for some of these applications. So when you want to connect a device to the cloud, and you don't want to worry about installing some special app on the phone, I'm very sure that we're going to see these kind of routing functionality in phones.
Like a hotspot or something like that, yeah.
Personal IoT hotspot.
Yeah.
It's going to take time for people to get there, but it's going to happen. I think we'll see it first in home routers, building automation routers, and things like that before phones.
Yes, I just a curiosity question. I like 15.4 a lot, but to me what's really exciting about it is the sub 1 gigahertz.
Absolutely.
You've got this great range, lower power, more than enough bandwidth with 20 megabits per second. It's great. In Europe, we got the short end of the stick because we have one channel compared to 15 in North America. But yet, I see very little 1 gigahertz hardware out there. I've always used the 1 gigahertz. But what percentage of the market do you see today in that 1 gigahertz spectrum? Because that's what's really interesting to me.
So the problem before was that these traditional sub-gigahertz 802.15.4 bands in 802.15.4 2006, they sucked. They were really bad. The performance was fairly bad, and the configurability was poor. So people never really used it. Everything was basically 2.4. And 2.4 has some success in homes, and Zigbee IP will make it a little bit better. Smart Energy 2, yeah. It'll never succeed in smartphones. That'll be BT Smart, absolutely. But recently, what's changed is that 15.4G came along. And 15.4G was basically everybody getting together and say, here's all the cool things that our chips can do with sub-gigahertz. Let's get it into a standard. And now what we see happening is an explosion of applications where we're using 15.4G for real stuff.
Of course, through concrete.
Yeah. Smart lighting systems, water monitoring systems, environmental systems, all the electric meter AMI reading systems that are sub-gig and using that technology. We'll see a lot more. Building automation, etc. And that's where we see the biggest growth of our stacks is in that space. So I absolutely agree. I'm most excited about sub-gig 15.4. I think that over time this will get better. So as we see Zigbee IP improve, Problem is, it's pretty narrow, the scope you can apply it to. As it improves, I think you'll see more things happening for home and building automation with Zigbee IP, which is 2.4. But Zigbee NAN is absolutely sub-gig. It's only sub-gig. So that would be the kind of the main market.
I think you're right, the problem is the hardware. There's a lot of 2.4 gigabits hardware out there. There's not nearly as much selection today in the 1 gigabit area, but
We're seeing more though. Like Atmel recently released a great sub-gig part. I think it's the 212.
yeah, that's what I'm using the 212 a lot. It's
Yeah.
a good chip, but I think it doesn't support the G standard. I think it's the wrong.
Well, the G standard is lots of things. So everybody supports a subset of the G standard. But that's normal. Nobody supports all of the G standard because it's like you can configure it for everything. That's why you need a profile also like Zigbee NAN, where you actually specify what settings do you use from the G standard. Otherwise, you'll never get like full interoperability.
Yeah, the 2 is a great chip.
Yeah. And as you see standards like this that push the radio technology, you'll see all the chip vendors actually able to support those settings too. So as we have something like Zigbee NAN, it'll pull the market, and you get everybody started. So you'll see a lot more silicon for sub-gig in the future.
Is this going to be branded as a Zigbee product? I mean, it's some confusion. You know, someone building a sensor with this stack, how would they brand it?
So, how do you brand your networks today in the internet world? You have Wi-Fi. What do you use Wi-Fi for? You hook up one more subnet up to your internet. That's it. Ethernet. These will be no different. We're still living in this paradigm where you have some of these leftovers from the Z-Wave, Zigbee days. You know, 5-10 more years, engineers won't even remember those. They'll be like, huh, those used to exist? Anybody remember Hyperland, for example? Not really anymore. They'll go away. And so people will talk about, oh, you've got the Zigbee IP network, the Zigbee NAN network, this BT Smart IP network, and they all are just pieces that build on your internet. That's what we'll see in the future. So we just have to be a bit patient, educate people. But the branding is really about what's the link layer technology you use to hook up to the internet. It's really as simple as that. So I guess it's our job as educators to teach people about this too. Yeah.
Yeah, sort of, I heard from some people that pt4, not cross-vendor compatible, maybe they didn't use Zigbee.
Absolutely, yeah.
What would tell you?
But it's the same, you know, it's really the same with any IP network. Even Wi-Fi networks, right? Yeah, Wi-Fi is compatible, but you still have some networking issues now and again, even with Wi-Fi. So it really needs some profiles, especially when you get into autonomous devices, right? You can hack your Wi-Fi settings on your laptop. I see a lot of Windows users doing that. Apple did a pretty good job with Wi-Fi on OS 10. But Windows users, I see them, and Linux users hacking lots of stuff. We don't have that possibility on a thing. If that thing has to be configured, we're in trouble. So Zigbee IP does that extra step, and it locks down everything. I mean, network authentication, it locks down how you do routing, everything is locked down. So it's certifiable. So we actually have to certify our stacks in Zigbee IP. So I think that'll fix part of that. But absolutely, 6LoWPAN by itself is not interoperable. You got to go build your network. So if you use it in a private network, fine. But if it's two vendors just making devices, you've got to use something like Zigbee IP or Zigbee NAN. Or BT Smart IP will be pretty interoperable too. We have L2CAP plus a pretty simple IP stack. You can make that work easily.
Yeah, so the case was actually the software was the same, but the chips were different things. But software was correctly the same thing. As in, rather maybe chip maybe was different, it's different radio rate, but the kind of the 6LoWPAN stack and the routing part was the same.
Ah, but the 15.4 settings were different.
Yeah.
Absolutely, yeah. No, these profiles have to build in all the 15.4 settings as well. That's actually the worst part. Like 15.4G, it's really a nightmare to get the same settings. You got engineers in a room for days to kind of figure out, oh, what modulation we're using in which way. It's actually pretty tricky stuff. 15.4 2006 was fairly easy. G has gotten worse, E is even worse. So we need the profiles to kind of navigate through the mess of options that we have in these standards. Great. Industry politics, that's what standardization is about. So yeah, you have a lot of people, a lot of money on the line, so people are putting a lot of technology and options into these things. So But I think we just then have to recover from that and do the smart things to make things interoperable again. So you kind of get that. Everybody's a gold rush. Oh, I got to get my thing in this standard, and then you come back to create something that's again the way to do it. It's just how the evolution of these things work. So it's going in a better direction, absolutely. All right, thanks. So I'm available all week. So come find me.